Hello everyone, welcome to Rare Chem Official. This video is about ionic radius. If you like this video, please like, share and subscribe. Without delay, let's get started. Ionic radius. Ionic radius is defined as the distance between nucleus and outermost electron of ion is called ionic radius. If take neutral atom of sodium, atomic number is 11, 1s2, 2s2, 2p6, 3s1. If lose one electron, it forms sodium ion. See, if you observe, first shell has 2 electrons, second shell has 8 electrons, 2, 3, 4, 5, 6, 7, 8. For neutral atom of sodium, number of protons 11, number of neutrons 11. Protons, it pulls electrons towards the nucleus, but electrons it moves away from the nucleus, means in outward direction. Whenever this happens, both get cancelled. Electrons revolve in suitable position around the nucleus. If take sodium ion, number of protons 11, number of electrons 10. Why 10 electrons? Because it lost one electron, so that's why it forms sodium ion. So number of electrons are 10 electrons. Whenever photons, here photons are dominating, photons moves towards the nucleus, size of cation decreases because one electron less. Here protons are dominating, so protons are dominating. Whenever it moves towards the nucleus, it decreases. The cation of sodium is decreases. Ionic radius of sodium is decreases. Sodium ion decreases. See, here we conclude that parent atom of sodium is greater than cation of cation or ion of sodium. See, ionic radius for anion. Before going to this ionic radius for anion, we will discuss one thing. See, here number of cells how many? 2, 1, 2. And for neutral atom, number of cells 3, because for ion of sodium it lost one electron, due to that one cell lost. and ionic radius for sodium ion is decreases, then parent atom of sodium. Ionic radius for anion, if take neutral atom of fluorine, the atomic number is 9 1s2, the configuration is 1s2 2s2 2p5. See, first shell has 2 electrons, second shell 1 2 3 4 5 1 2 3 4 5 6 7 7 electrons. See here outer configuration is 2s2 2p5. It in this one electron is less to noble gas configuration. Whenever gains one electron, it attains noble gas configuration ns2 np6. Means here fluorine gains one electron, it forms F minus ion. Whenever F minus ions forms, see, if fluorine atom, how many electrons, how many protons? 9 protons. How many electrons? 9 electrons. See, protons always pulls electrons towards the nucleus. Uh, if electrons try to move away from the nucleus, whenever this happens, both gets cancelled. Whenever it cancelled, electrons revolve around the nucleus at suitable position. For F minus ion, the number of protons 9, number of electrons 10. Here electrons are dominating. See, electrons are dominating. If electrons move away from the nucleus, the size of F minus is increases. Ionic radius of F minus is increases because it moves away from the nucleus. Here we conclude that ionic potential for parent atom is less than anion, means F minus ion. If we observe in groups from top to bottom, number of cells increases. From top to bottom, ionic radius is increases because number of cells increases, screening effect increases. Screening effect increases, it is very difficult to pulls electrons from the valence electrons. So it is difficult to pulls electrons towards nucleus. Nucleus from valence cell. So size of F minus is increases. Ionic radius of F minus is also increases. From top to bottom, size increases, ionic radius increases from top to bottom. If take first period lithium, sodium, lithium ion, sodium ion, potassium ion. The number of cells increases. See, from lithium to potassium cells are increases. Ionic radius also increases. From left to right, ionic radius is decreases. Because atomic radius is increases but number of cells remains constant. So ionic radius is also decreases from left to right. That's all for today. Thank you for watching.